Hello everyone. In the last videos, what we've done is create the tables, talked about the business rules and how the tables needed to be created, some of the design considerations, talked about the data types that were used. We also populated the tables, and we discussed obfuscating data, that is, preventing users from seeing sensitive data if they were able to gain access to a particular table. We obfuscated the social security numbers in the person table by hashing the values using the SHA-2 512 hash value. So we created the tables, populated tables. What we're going to do now, we're going to talk about the money code or the money SQL. And what I'm somewhat facetiously I'm referring to is the code that is rather a bit more complex and is going to be able to do a number of things for us. It could either provide us with detailed information. It could help us create time-variant data, historical data for logging purposes, also for governmental regulations, and other things as well too. So this is really the more complex code after we get done designing our tables and populating them. Let's begin. The first exercise is to create a view that displays the sum of all paid invoice totals for each customer, sort by the largest invoice total sum appearing first. Gang, I've told you a number of times that you always want to break down the most complex report or SQL statement, break that down into smaller parts, then begin assembling and putting the smaller parts together into a larger configuration. A couple things though before we begin. Let's take a look at some of this code here. Here we just want to see what tables we've created, and you could use this code to do so. Okay, so list the tables. And you want to use, again, make sure you supplant your FSU ID instead of mine. So everywhere you see MJoette, just put your FSU ID there. And I'm going to go in here and paste this. And you see there are the tables listed. And you can see the tables right here, right? Listed, and you'll see the same thing when you do invoke this code. Also, we could see the metadata for each of the tables. Now, there's quite a bit. You're going to see there's quite a bit of metadata here, and if you want to, you can do some further research and take a look at it, view the various columns here, the data, the values that are revealed, and if you want, you can further pursue some research on the internet and find out what all of these columns mean and with respect to the tables that you created and attributes. Another one that's very helpful is it's really a summary of your tables. And what you would do is use the intrinsic stored procedure that Microsoft SQL Server provides. And another thing, gang, when in discussing this, as I mentioned in class, try to refrain, matter of fact, you should refrain from using the SP underscore prefix for naming your store procedures. Here you're seeing that Microsoft SQL Server has a built-in, what we call an intrinsic store procedure, and it's specifically used to provide metadata for your particular table. Put a space after it and wrap it in single or double quotation marks with the DBO prefix indicating database owner dot table name. And what it will do, it's somewhat similar to a describe in MySQL. Now, it's not identical, but it's somewhat similar to that. And as you can see from the return, it's providing metadata as well too. A bit more metadata that you would get from MySQL's describe statement, but nevertheless, it provides additional information. Like, for instance, here you could see the primary key for the sales rep history table, SHT underscore ID, the seed, the beginning value is 1, and the increment value is 1, as we discussed when we were actually defining the table requirements in a previous video. All right, let's begin. So with that prefix here, or with that, I should say with that preface here, you have various ways of seeing your tables, seeing the metadata, and now we want to go to the actual exercise. So create a view that displays the sum of all paid invoice totals for each customer, sort by the largest invoice total sum appearing first. Gang, as always, break it down. Break down the most complex SQL statement or report that your boss wants. Break it down to the subsections. It'll make it a lot easier when you put everything together. So as always, upon opening up the SQL editor, you want to use your database name. Use the go command, which is essentially synonymous or somewhat equivalent to a batch command. Everything above it will be processed in a batch execute command. Everything above the go statement. And what that provides is that you could have multiple go commands, and if you put everything all in one, everything in the SQL editor, and some of the statements don't work, then none of the statements will work. But if you use these smaller go commands and put your SQL statements in each one of those, you'll see that even if some statements don't work, the others will, because they're processed individually. Again, everything above the go command will be processed like a batch. I don't have to do this because I've already done this, but let's take a look at the snapshot of all the invoices. So we'll do this, process this. And we're just seeing the snapshot of all invoices. And we could tell here what's paid and what's not paid based upon the bit data type that we talked about in the previous video. The bit data type, 0 means that it's not paid, 1 means that it is paid. And we use the bit data type because it is a small, it only consumes one byte of storage space. So it's very small as far as consuming storage space. So here it is, this bit data type here. Notice the zeros, notice the ones, and now what we want is a snapshot of all paid invoices. In other words, those whose value is 1. So there should be only 1, 2, 3, 4. Let's do that. Paste that in. And in fact, that's all you see. 1, 2, 3, 4. Okay. Next, what we want is a snapshot of the sum of all paid invoices. Okay. So let's see the sum of all paid invoices. Okay, there it is right there. Now what we could do is go here and create the view. We have an overview of the smaller portions of the requirement here, and that is to create a view that displays the sum of all paid invoice totals for each customer, sort by the largest invoice total sum appearing first. Now, I got something here that I think you'll find interesting, and that is I have a print statement. Now, the interesting thing of that is the print statement won't work in grid view, as I'll show you here in a second. It won't work in grid view, so we're going to change the view here in a second, and you'll see how it will, in fact, work. Okay, so let's go to the code. Here is your answer, okay, right here. Now, a couple things. We're creating the view. Remember, just like in MySQL, create the view name as, make sure you use that as keyword. And then the most important thing, gang, the most important thing is this select statement, right? It's not the view syntax, because once you do that, all you do is create it as a template, and you could use that over and over again by just changing the name of that particular view. You do the same thing with a store procedure, trigger, etc. Now, you may add, for instance, in a store procedure, you may add parameter values, but apart from that, the syntax is pretty much the same. One thing I want to say, in Microsoft SQL Server, you shouldn't use the order by clause in views. you could use them in store procedures, but not in views. If you want an order by clause, you use it in the call of the view. So when you're actually using the view, you want to then put the order by clause in there, as I'm doing right here. Okay? So after you create the view, then just use the order by clause when you're excuse me, when you're using calling or selecting the view itself. Okay? All right. So here's your answer right here. I'm going to do the print command, and we're going to then call the view and see what it looks like. Okay, there's the view. There it's giving us the sum of the paid invoice total for each customer. We have their first name and last name too, and we also make sure we have their person ID. The reason we put the person ID there is so we can go back to the subsections that we did here. When we broke down this view, when we broke it down, and we could see exactly if the totals match up to the snapshot of all the invoices, the paid invoices, and the sum. We could see if that actually adds up. All right. There are some other things I want to talk about. The first thing, though, I want to talk about is notice how this print statement did not display. And it won't display because we're in grid view. So what we do, we could right-click on here and do results, and then show the results in grid view like this. So all I have to do, nothing's changed. I just run the command again. And now, excuse me, I mistakenly put it in grid view rather than text view. It should be in text view. Okay, put it in text view like this, and then run it again. And now you could see that the print statement is working. Now, why the print statement is good is because it's indicating the grid view you can't do that. But text view, you could say, okay, what is this query result returning? And so we could say in our print statement, okay, this is the solution. It's going to create a view, sum of all each customer's paid invoices. All right, there. So it's indicating what is below it. And that's why I like to do this sometimes. But other times I like to show grid view because it just takes up too much space. But in this particular situation, it works nicely, and you could print it like that too. So it's a nice way to run a report if you want to do it for testing purposes, show your boss or your client. Another thing, be careful here, gang. I have a comment here. Use a single quotation mark to escape single quotation mark. Otherwise, there's going to be an error. And also notice the additional space for the line break. So I wanted a line break here, and what I did was I just made that additional space. Okay? Watch what will happen. Number one, if I don't include this escape sequence, okay, I want an apostrophe here for the possessive form, right? Customers paid invoice, possessive. And so I'm going to print this out just like this for testing purposes. Okay, I'm going to do that. And try to print this out. I hit F5. Notice there's an error. So the way to get around that error is what you do is you just escape it with another single quotation mark like this. Okay? The other thing, notice what happens when I don't use the space there. Okay, I'm going to try to print this out again like this, no space. And I'm going to go back here and Control A, Control V. Notice I want built-in space, right? If I don't do that, then it's a little bit crowded here, right, before the query results. So I want to build in that space like this, and I do it like that. Okay, so one more time. Here is the full solution. Actually, all you need really is this, right? Don't forget, put your order by clause in the call of the view, not in the view itself for SQL Server. You can do it in MySQL, but not in SQL Server. Let's put this all together. And here, and we'll even include the tables. Okay, so, all right. Now, I'm going to scroll up here just to show you the, okay, there's a return, as I showed you before. Okay, here's a return right here. Now the tables. I'm going to put the tables in grid view because it's just too scattered. See what happens sometimes in grid view? You got to scroll all the way to the right to see the tables. So what I'm going to do now, another way, just so that you know, if you want to permanently change it to either the grid view or the text view, or even permanently change it to put the results in a text file, just go to Tools, go to Options, go to Query Results, click on Query Results, and from there, this is going to change it permanently, right? When you right-click on the actual query window, that'll do it temporarily. But if you want it permanently, you just go to the Tools and Options, and then you can select there. So my permanent display is Grid View, because it's more concise. But if I want to change this temporarily, all I do is right-click on here, go to Results to Text. Here I'm going to show Grid because I want you to see the tables, and I can go back and forth here temporarily, modifying the view, the display. Here I'm going to show you that it's going to be a little bit cleaner if we run this in Grid View, and there it is. Notice all the tables, and notice also what SQL Server does for us. It will indicate whether that table is a base table or a view. Now, when we do show tables in MySQL, it shows the table it shows the view as a table. So that's why it's important to name your views V underscore, right? So you can see all your views listed as a table, because there's no such command in MySQL as show views. Now you can see the views similar to this in MySQL, but you have to go into the information underscore schema database to do that. Rather somewhat similar to doing this as well. And MySQL will indicate the difference between the base table and the view. But if you just do show tables, you can't tell if it's a table or a view in MySQL. Here, SQL Server indicates that in fact is a view. Okay, let's go to number 2. Number 2, create a store procedure that displays all customers' outstanding balances. We're going to have an unstored derived attribute based upon the difference of the customer's invoice total and the respective payments. So here's the code. Remember, the most important thing is the select statement, right? Here we're going to do it for an individual customer just for testing purposes. So we're going to do this. Put that in here. Control A, Control V. F5. We're going to hit F5. And there it is for an individual person. Hank Pyme. Okay, that's his name. Come up with these unusual names. So the total paid and then the invoice difference. So what we want is to display all the customers' outstanding balances. So if there is an outstanding balance, it will display it. And here, that is indicating there's an invoice difference. And the a couple things here. Number one, we're using an aggregate function twice, sum of payment, and then we're using it here as a derived attribute. Invoice total minus the sum of the payment is the invoice difference. So whatever the invoice total is, minus their payment will give you the invoice difference. And if it's positive, it means that there's an outstanding balance, right? Because the invoice total is what is owed minus what is paid. If there's a difference, if it's a positive difference, that means that's what is owed to the seller. This is what is owed to the seller. If it's a negative difference, it means that the seller, that the buyer has a positive balance. In other words, the seller owes the buyer money. Okay? So, what's happening here is we're using two aggregate functions, actually one aggregate function, but we're using it twice in two different areas. And because we're doing that, we're using a aggregate function with non-aggregate attributes. And because we have to do that, SQL Server requires, now MySQL requires we use a group by too, but we don't have to use it for every attribute. SQL Server requires that you use the scalar attributes, the non-aggregate attributes in the group by. Each attribute that's not used with an aggregate function, including invoice total in this derived attribute, must be used in the group by. Otherwise, you'll get an error. So any attributes that were not used in an aggregate function must be used in the group by clause. All right, here's the actual answer right here. Okay, and so remember, the most important part is the SQL statement. Notice our joins and how we're doing our joins. Remember, in SQL Server, we cannot use a natural join. We cannot use a join using. We must use a join on. Gang, as always, whenever you have the luxury of having your an ERD, always use that. Take advantage of that ERD because it'll make your writing your SQL so much easier. You could see it as a roadmap. What do we need? Well, we need here, number 2, create a store procedure that displays all customers' outstanding balances. Unstored derived attribute based upon the difference of a customer's invoice total and the respective payments. List our invoice totals, what was paid, and the difference. Now, how do we find the customers? Well, if we want their names, we have to go to person, to customer, to contact, to order, to invoice, to payment. So 1, 2, 3, 4, 5, 6 tables. Remember, we've talked about this many times. 6 tables, always one fewer number of joins. What do we have? We have 6 tables that we're using, and notice that we only have 5 joins. Okay? So 6 tables, person, customer, contact, order, invoice, payment, and 5 joins. There's our joins, 1, 2, 3, 4, 5. All right. What else is important? Well, anytime that, and by the way, as mentioned, we can use an order by clause inside of a store procedure, but not inside of a Microsoft SQL Server view. We can use an order by clause in a store procedure, though. One other thing, notice the order table. Our order table is a keyword, so what we have to do is make sure that our order is wrapped in brackets. If we don't wrap it in brackets, we're going to get an error. And I also put that in here as well, too. I guess I didn't put that here. My apologies for not indicating that. But it's the same thing here when we did the individual customer. Because order is a keyword, we have to wrap it in brackets like this. Okay? We do that the same thing in MySQL, right? We did that in a previous assignment when we used the case keyword, C-A-S-E. We had to wrap it in backticks. Here we wrap it in brackets. Okay, now, one other thing here is that we're going to put this in text views so we can use the print statement, and we're going to then run the stored procedure. So I'm going to do this. I'm going to go here and execute that. I'm going to create it and then execute it. Okay, copy that. And then what I'm going to do here is change the view, the results to, I'm going to change it to text. Do that. Notice it doesn't change until I actually run it. Control A, Control V, and then F5, and there it is. So the solution, create a procedure that displays all customers' outstanding balances. Notice these negative values. Again, as I mentioned, the positive values means that the customer owes money, their outstanding balances. The negative values means that the seller owes money. So they paid their balances, and in fact they have a negative balance that is due to them. The customer is owed $12.55 here, right? The positive ones are what the seller is owed by the buyer. Okay, there it is. Let's take a look at our procedures. Let's take a look at our procedures. We can list all our procedures like this. Control A, Control V, F5, and there's our procedures. We could put that in, we could list it also in grid view if we wanted to. So we can go here and list that in grid view to see. It's a little bit easier to read perhaps, but you can't print it out in grid view. So Control A, Control V, F5, and there it is. Again, the metadata for that particular store procedure. It shows all our store procedures here just by invoking this command. And also, by the way, this command will also show functions as well too, not just procedures. Microsoft SQL Server calls functions and procedures the same thing. So where routine type is procedure. And we now, if we want to display the definition of a trigger or a store procedure or view, we could just do this, sp_help text for this particular store procedure. We could show that as well, like this. Control A, Control V, paste. And there's essentially the create statement for that store procedure. And we could use that if we want to recreate it. But again, here is the solution for that. Notice we're using our begin and end statements as well too. Okay? Don't forget to put the brackets around the order table. Otherwise you'll get an error. All right, let's go to number 3. And then after, gang, if you're not going to use the store procedure, make sure you remove it from memory. Okay? We're going to keep it there for now. All right, number 3. Create a store procedure that populates the sales rep history table with sales rep data when called. Okay, so we're going to do number 3 here. And I just want to say one thing. Both tables have existing data because in our populate statements above in the first 2 videos, we created the tables, we populate them with 5 records each. But I want to show here a technique that you would use if you wanted to do, say, an initial population of a logging table or a history table. Say that you created this product history table or even the sales rep history table after the fact. Say, okay, we got this product table. We want to have a history table now. We want to start tracking historical data. So what you could do is this. We already have data. You'll see that we have 5 records here. What I'm going to do is actually I'm going to purposefully delete the sales rep history table because we already have 5 records. I'm going to purposefully delete them, and then I'm going to execute this store procedure to show you how it could populate the history table from all of the existing base table data. So we're going to delete the product history table on purpose, and then we're going to populate it from the existing product table data. Okay? Let's look at the code. First of all, here's the answer right here. Okay? There's our store procedure. let's look at what we're doing here with the actual insert statement. We're going to insert into the table history table, and then what we're going to do, gang, here is we're going to do a select all from the sales rep table. I'm sorry, I was talking about the product history table instead of the sales rep history table. It's the same principle, though. The sales rep table here is the base table. And what we're going to do is we're going to delete everything from the sales rep history table and show how we could populate the sales rep history table with existing and with dynamically mixed data to populate the sales rep history table. Same principle would apply to the product history table. Okay, so we're doing the sales rep history table, not the product history table. And what we're doing is we're going to take the we're going to insert it to the sales rep history table, use the attribute names, and we're going to mix dynamically generated data. So the person ID, we're going to grab that from the sales rep history, from the sales rep table. We're going to insert that into the sales rep history table. We're going to say that it's going to be an insert statement. We're going to use the get date function. We're going to use the system user constant to find out who that system user is, and we're going to use the get date here. So we're going to say, what is this for? For the sales rep history, when was it modified, who the modifier was, and the sales rep history date. So normally this would be different if we had existing data, which we do, and I'll show you this in a second. But what we're trying to accomplish here is to pretend that we never had a sales rep history table, and that we're now going to create one and then populate it with existing sales rep data. And so if you had thousands of records, that would be quite a formidable task. This code makes it a lot easier to do. It'll automatically do that for you and mix dynamically generated data. Let's begin. First thing I'm going to do is I'm going to change the view here to a results to text. Okay. I'm going to show the print statement. I'm going to drop the procedure if it exists. I'm going to create the procedure. I'm going to print the table data before the call. I'm going to delete all of the existing sales rep history table data because, again, we're simulating initially populating that sales rep history data. I'm going to make a call to the store procedure and then list the data again. So let's do that. Copy it, paste it, run it, and let's take a look now. So here is the initial call. You could see the data here. So here's my sales rep data. Here's my sales rep history data. Okay. Oops, my apologies. It's up here because they both should be 5. Here's my sales rep data. Here's my sales rep history data. Notice the sales rep history data is 1 through 5. Okay? Notice the sales rep history type, insert, insert, update, update, insert. Now what I'm going to do is delete the data to show you how we could populate it based upon the existing sales rep data. So we're going to insert into the sales rep history table based upon the sales rep data and mix some dynamically generated data with it. In other words, we're going to put an I there for insert. We're going to get the date, use the system user constant, and look what it is now. So previously, the sales rep history included this, saying that it was modified here June 30th. Okay. Now let's take a look here for we delete the sales rep history table, okay? We delete that, the existing sales rep history table data, and notice the new auto increments. The new auto increments are not 1 through 5. They start now 6 through 10 because we deleted that initial data. So taking a look here, look at the sales rep data, look at the new sales rep history data, and we populated that. We indicated who the modifier was and when this was performed. So it's very valuable to be able to populate a logging table or a history table if you never had one. And the way to do that is by just using the existing data from the base table and then populating that with an insert statement. And it's very easy to do like this. Okay, again, here is all the code. Here is the correct answer for that. All right, gang, I'm going to stop this recording right now, and then we're going to finish up with the remaining triggers, 4 and 5, and then the extra credit. See you in another video.